In this video, I'm going to begin teaching you about motion time graphs. I'm going to start with position time graphs using a PHET simulation. Look at the y-axis for me and note that we are looking at the horizontal position in units of meters. So our maximum value is 10 meters, and that's a positive 10 meters. And recall from previous videos, that can also be expressed as 5 meters to the right when describing a vector quantity. Notice my least value here, my smallest value is negative 10 meters, which I could also say 10 meters to the left. However, I would never say negative 10 meters to the left, and we've gone over that in previous lessons. In this video, I want you to just begin to understand position as a function of time graphs. I will then take this same graph and we will begin to analyze it. For now, I just want you to start to understand how motion can be represented graphically. I want you to look for several things in particular. I want you to look at the slope. I want you to compare the magnitude or how steep the slopes are. I want you to ask, is it a positive slope or a negative slope? I want you to note areas where the slope equals 0. And recall the slope is simply the change in y values over the change in x values, commonly referred to as rise over run to find that slope. Lastly, I want you to look for areas that have curvature. These are all very important. Before I start the simulation, let's look at the moving man. The moving man is at position 0. So this is position 0. This is our initial position at 0 meters. Graphically, we're going to be starting right down here at 0 meters at 0 seconds. So on the x-axis, we have time in seconds. So the entire duration of this motion is approximately 20 seconds, and I'm going to break it into 8 different segments so that in the next video we can analyze those 8 segments. Let's go ahead and start with segment 1, which is approximately 2 seconds. Notice the man moving off to the right. Man moves off to the right at approximately the same speed. In other words, you didn't notice the man speeding up anymore once the man started in motion to the right. So we have a positive slope. That slope is constant, and this man has moved approximately 5 meters to the right. Graphically, we see this as positive 5 meters. In the next segment, which is also approximately 2 seconds, we see the man sitting here, standing, staring at us. Position is not changing. Now look at the graph. Look at 3 seconds. What is the man's position at 3 seconds? His position is 3 meters to the right. What is the man's position at 3.5 seconds? It's still 3 meters to the right. In other words, where we have a slope of 0 on a position time graph, the man is not moving. The object is stationary during that period. Now, as we enter segment 3, I want you to make note of the slope, the steepness of the slope compared to segment 1, and also the value as far as it being now a negative slope compared to a positive slope in segment 1. And you can tell the man has already turned around and is now going to be moving to the left for approximately 2 seconds here. However, as you notice, his motion now, he's moving with a a greater speed. So he's moving to the left now, but he's doing it faster. However, his speed is still constant. It's simply greater than the speed in segment 1. Now this man's position is 4.7 meters to the left, or negative 4.7 meters. So notice that this man has gone beyond the starting position. And so graphically, we see the graph come below the x-axis. So on a position as a function of time graph, anytime this motion is graphed beneath the x-axis, that means that the object has gone to the left or in the negative direction. This could be to the west. Remember unit knot videos. This could be to the west. But that's a good reference point when analyzing these graphs, which I'll teach you about in the next video. Now, you can probably predict what this man is going to do between 6 and 8 seconds, and he didn't move. So between that time, this man was not moving, and I can back us up a little bit so we can see the moving man staring out at you. Okay? He was stationary for those 2 seconds, and again, we note slope equals 0 between approximately 6 and 8 seconds. Now, let's look at this motion between 8 and 10 seconds. What do you notice? It's different, isn't it? There's curvature to this graph, and that is going to be very important moving on to actually analyzing this graph. So let's watch what the man does between approximately 8 and 10 or 11 seconds. The man changed direction. The man is moving to the right. The man is approximately 0.2 meters to the right of the initial position. However, you should have noticed that the man sped up. So that rate was changing over time. It was increasing, which means the speed was not constant. The speed was increasing over time. In other words, this man was accelerating to the right. Now, in this next segment, we're going to see another event that's different. Note there is curvature between 10.3 and approximately 12 seconds. Note that there is curvature, but it looks different, doesn't it? And this, in fact, is going to be where, again, the rate is changing. The rate of speed is changing, but in this case here, it's decreasing, which means the man is decelerating. The man is slowing down. Let's watch these next couple segments here. Okay, we see the man begin to slow down, and I'm actually going to play it all the way from 8 to approximately 11.8. Here we go. Speeding up, slowing down, boom. Getting ready now to change direction. So we saw an increasing speed over time. We have a segment where it was somewhat constant here. However, then right around here, right after 10 seconds, we see curvature that's very pronounced again. And indeed, this is where the man is slowing down. So it's another acceleration, except this acceleration is now in the negative direction or to the left. All right. In this penultimate segment of the graph, we see a negative slope between 12 seconds and a little past 18 seconds. I want you to compare the steepness of that slope to other segments, namely segment 1 and segment 3. If you compare it, this is not as steep. So it has a smaller magnitude when compared to segments 1 and segment 3, respectively. In other words, the man should move to the left at a constant velocity. Think about it, guys. The slope between 12 seconds and 18 seconds is constant. No matter where you found the slope, it would be the same. The rise over run would be the same. In other words, this man has a constant speed or a constant velocity to the left, but it is smaller in magnitude than either segments 1 and 3. And you can see the man moving to the left, passing the origin, now beyond the origin, and stop. Look at us again. And for the final 2 segments, which should be right above my head, you should see a blue line right above my head here. The man is going to stay stationary out until 18 seconds, or excuse me, 20 seconds. And that is the end of the simulation. I'm going to now speed it up, play it one time all the way through. I want you to hopefully have sketched this and made some notes about this position as a function of time graph. We are back to position 0. So your eyes should be watching the man on the top, position 0, but graphically we are starting on the far left at position 0 at the origin, and I'll play this simulation one more time through. Man is moving to the right, stops, moves back to the left, stops, accelerates to the right, slows down, turns, moves back to the left with a constant velocity, and then stops. Okay, so this man's final position is negative 3.0 meters, right around negative 3 meters. In other words, this man's final position is around 3 meters to the left of his initial position. Okay, so now we're going to take some time to analyze each of these 8 segments for this position time graph. And I'll see you guys in class.